Good evening. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. Here on this 28th day of February, last day of the month, and turning from summer into autumn as of midnight. Anyway, new season, end of summer and autumn starting, and hopefully that'll be the end of the extremely hot days, but I don't think it will be. I'm sure there'll be a few more hot days in this weather pattern over the next few weeks. Nevertheless, a very pleasant good evening to everybody tuning in for the first time. This is VK3EKH, the official station of the Astronomical Society of Victoria, probably the biggest society, astronomical society in the Southern Hemisphere, at least amateur orientated at least. And we're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater, TV repeater, VK3RTV, digital channel 1 HD, which is viewable on 445.5 megahertz with a DVB-T2 set-top box. And all that information about being able to receive RTV is available on Amateur Radio Victoria website. There's a dedicated page to receiving RTV, and a list of receivers that one can get if they're still available to be able to receive the repeater if you're within range. And also on my Discord channel, as every week, I mention that Discord is probably the better way to view the video side of the presentation here tonight, or every Friday night, apart from the ATV repeater, as in the fact that the vision is less than a second delayed to what you're hearing on me on 80 meters, whereas with YouTube, there's anything up to 20-second delay. So we do have a YouTube stream running, of course, nevertheless, and you can find the live stream on YouTube, of course. Just type in VK3CSJ and look for the live indication, and hopefully within this next hour we won't have the Telstra modem falling over due to RF getting into it. Normally, I've noticed that the modem hangs in there for the full hour, for the full duration of the broadcast. It decides to fall over when I decide to open up the frequency for a little bit of callback. It's as soon as I intermittently transmit, it's when it gets upset. Nevertheless, we'll see how we go. All right, what else? And like I say, we're on YouTube as well, and the Discord HD stream. With Discord, there's a chat room, astronomy chat room, where you can have conversations with other folks that join in. The Discord, you need to go to the website, Discord website, and sign up. There's no funds involved; it's just signing up. And once you've passed that process, I provide a link to the chat room on my QRZ page. Just type in VK3CSJ or VK3EKH for that matter. On both QRZ pages, there's a link I provide that'll take you straight to that Discord chat room and the HD stream. We also have an email address if you wish to send a signal report and let me know how the audio sounds, if it's too much or too less and not enough and whatever. VK3EKH at gmail.com, VK3EKH at gmail.com, which I think I've got running here. No, yes, no, now I do. So I shall just go to that inbox. Okay, so we're watching that now. All right. Now, being the first of the month, well, close to it, there's the Sky Notes. Oh, actually, before I do, go into the Sky Notes provided by Tanya Hill, the resident astronomer at the planetarium. Let me just read out the usual blurb about the society and what it's all about, in case you just don't know this information. And I really should make a recording of this so I don't have to bother holding the book in front of me and reading the same thing every Friday. The Astronomical Society of Victoria was founded in 1922 and comprises over 1,600 members throughout Victoria and the other states of Australia and overseas. Membership of the society is open to all persons with an interest in astronomy. The society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mullier Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory. And I just recently donated a book to the library. The Sasha Sagan, Carl Sagan's daughter, has written the book. And for some reason I ordered 2 of those books. I don't know why I got 2, but anyway, I didn't need 2, so rather than send the book back, I ended up donating it to the society. So she should, the librarian should have that by now. Apart from all that, where was I? The books, yes, periodicals and other publications from the Society's extensive library located at Melbourne Observatory. Receipt of the ASV's magazine called Crux, containing articles, news, observing notes and the like, and free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try before you buy, sort of thing. Regular Society Club Night meetings are held held at Melbourne Observatory in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in how to use a telescope. These instruments include a 508mm equatorial reflector and a number of small reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger 2 with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable radio telescope, 8.5 metre, 30 foot in the old measurement, which members can access with involvement in the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, including historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook. If you've got access to a yearbook, further information may be obtained by visiting the ASV website at www.asv.org.au. That's www.asv.org.au. Further information, yes, I've just said that, and also information is given in the what's referred to as the Crux Extra Bulletins, which is a email that is sent out to members every other week, just to keep members abreast of what's coming up in the society. Please note that ASV will conform to all government health directives, thus ASV events may be required to be cancelled, moved or postponed. If you wish to send a mail to the ASV, address your envelope to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. In fact, if you've got a book you want to donate to the Society, that's the address to send it to as well. Okay, so that's that. In fact, this weekend is the Messier Star Party happening tomorrow. I think they've got favourable weather for that. For those watching the video side of things, this is the information you need to know well, at least some of the information you need to know about the Messier Star Party, which again is tomorrow. I don't believe it's booked out. I haven't seen any references to it being totally booked. So it is open to the public. So I would suggest that you go to the ASV website if you wish to go up there and organise a ticket. There is a ticket. There's once you register that, and the information about how to get there is then sent to you by some other method. Yes, if the Star Party works out okay tomorrow, I don't think the weather's going to be too bad. There'll be plenty of telescopes set up on the field. Usually the observation field is covered with telescopes around the perimeter, and the Obsession telescope, which is the 25-inch telescope, usually dominates the central part of the observation field. And if you ever wanted to find out what it's like to look through real telescopes, this is the place to go to. And any of the astronomers up there with their telescopes on display will be quite happy to talk to you about how it works and how much it costs, and essentially what would be a good starting telescope for if you've got a kid that's interested in astronomy and all that sort of stuff. So the Messier Star Party tomorrow, 1st of March. And like I say, if you visit the ASV website, www.asv.org now, and organise a ticket, you'll be able to get up there. That's tomorrow. Okay, this is ASV Radio, VK3 Echo Kilo Hotel. Time is 10:14 already. Good grief. Right, let's go to Sky Notes, provided by the Science Works Planetarium, and we'll just go to the top of the screen here. Okay, so it starts off with the reference to the autumn equinox. On Thursday the 20th, we reach equinox with equal lengths of day and night. Autumn equinox in the southern hemisphere, and spring or vernal equinox in the northern hemisphere. We are midway between summer and winter solstices, and other planets' axes. Our planet's axis leans neither toward nor away from the sun. Melbourne sun times. On the 1st, tomorrow, sunrise will be at 7:04 a.m. setting at 7:59 p.m. with the average day length at 12 hours 55 minutes. On Tuesday the 11th, sunrise will be at 7:14 a.m. setting at 7:45 p.m. With the day at 12 hours and 31 minutes. Then Friday the 21st of March will be sunrise will be at 7:23 a.m. setting at 7:30. Day length 12 hours 06. And then by the end of the month, on Monday the 31st, sunrise will be at 7:32 a.m. setting at 7:15 with the day shortening to 11 hours and 42 minutes. Moon phases. There is a first quarter on Friday the 7th. There's a full moon on Friday the 14th. There's a third quarter on Saturday the 22nd. And by the end of the month, there will be a new moon on Thursday the 27th. Moon distances. Lunar apogee furthest from the Earth is on Tuesday the 18th at 406,295 kilometres. Lunar perigee closest to the Earth. Did I say furthest from? Yeah, I did. Closest to the Earth, perigee is on Sunday the 30th at 358,128 kilometres. You could almost throw a stone at it. Lunar. There is a partial lunar eclipse this month. On the evening of Friday the 14th. On the evening of Friday the 14th, a partial lunar eclipse will be visible from Melbourne. A total lunar eclipse will have occurred for the Eastern Pacific and most of the Americas. Then, as the moon rises for Eastern Australia, observers in Melbourne can catch the latter part of as a partial lunar eclipse as the moon moves out of the Earth's outer penumbral shadow. A high location and a clear view of the eastern horizon is recommended, as the moon will have just risen and the event will be all too brief. So that's Friday the 14th. Look to the east. Moon rise will be at 7:40 p.m. Maximum from Melbourne will be at 7:42 p.m. Partial eclipse ends at 7:47 a.m. and the penumbral eclipse ends at 9 p.m. according to this information here. Okay. Total lunar eclipse. The next total lunar eclipse is later this year. In the early hours of Monday, the 22nd of September, Melbourne will experience, actually there's a little graphic here that I can bring up on the screen, which I did save, and I'll bring that up. So this article is referring to this right now. Later this year, in the early hours of Monday, the 22nd of September, Melbourne will experience a total lunar eclipse as the moon passes through the deepest part of the Earth's shadow, or the umbra. Totality for that eclipse will last over 80 minutes from 3:30 a.m. to 4:52 a.m. After that, the next total lunar eclipse for Eastern Australia will be in 2026 on the night of the 3rd and 4th of March with totality almost 1 hour. So stay tuned for that one. I'll remind you guys. Anyway, so but essentially that little diagram we're seeing on the screen right now is how it all works. Discover more about the moon's orbit and eclipses with videos and simulations, which are provided via a link here on the what they refer to as the NASA Science Visualization Studio Moon Essentials and the PBS series Lunar Eclipse Explained. They are all links available on the Sky Notes. Just type in Sky Notes for the Melbourne Museum Victoria, and you'll get this same information that I'm reading from. In fact, these Sky Notes you can request to be emailed out to you as well. Okay, planets. Mercury this month is an evening object, but not visible from Melbourne's latitude. Venus is not visible this month as it is about to pass in front of the Sun for its inferior solar conjunction, when it will be conjoined with the Sun from our perspective. Next month, it will return as the morning star before dawn in the east. Let me just go back to camera. Mars is an evening planet seen from 8 p.m. in the north at dusk until it fades from view in the northeast by 1 a.m. It's quite an obvious object in the sky. You can tell by the reddish tinge. That's Mars. And it's not twinkling either. Planets don't twinkle. Mars is an evening planet, so seen from about 8 p.m. in the north at dusk until it fades. Jupiter can be seen in the evening twilight in the north from 8 p.m. until it sets in the northwest around 11:40 p.m. Saturn is not seen this month as it is about to move behind the Sun for its solar conjunction, but will reappear in the early morning next month just before sunrise. Meteors. The Alpha Centaurids and Beta Centaurids are active from the 2nd to the 25th, peaking on the 8th of March. They are different, but it is difficult to distinguish between them, the Alpha and the Beta. Occurring low in the south near the two pointers. So if you look towards the south to the two pointers, they are not strong showers, but often have fireballs and persistent trails. It can be anything up to 25 per hour can occur, but usually 6 per hour has been the norm over the years. So that's the Alpha Centaurids, and the Beta Centaurids are active between the 2nd and the 25th. Stars and constellations. If we turn our chair to the eastern part of the sky, high in the sky is Sirius, the brightest star at night, and the principal star in Canis Major. This is one of Orion's 2 hunter dogs, which is why Sirius is also referred to as the dog star. Directly below Sirius is the star Procyon, I think that's how you pronounce that, which marks the location of Canis Minor, which is Orion's lesser dog. And they've got there's a little picture here of this star. Let me see if I can just bring that up. Okay. So what we got here is Sirius A and Sirius B, taken by the Hubble Space Telescope, which you can see on the screen right now. It's an overexposed shot, actually, an overexposed 2003 Hubble Space Telescope image of the Sirius binary system. It's a binary arrangement designed to reveal Sirius A's very faint companion. Oh yeah, it's to the bottom corner there. Sirius B, which can be seen at the lower left, the spikes and the ring patterns radiating from Sirius A are byproducts of the telescope imaging system. Okay. Now I didn't quite finish that article, that part. What are they saying here? Yeah, Sirius is, however, a binary system. Sirius A is twice the mass of our Sun. almost 17 times as large and 25 times as luminous. Small, faint Sirius B, however, was once a star similar to our Sun, but in its late evolution it lost its outer layers to leave behind an extremely hot, dense remnant core, a white dwarf, a little smaller than Earth, but the mass almost that of the Sun. Sirius A and B orbit their mutual centre of mass every 50 years. So that's one object to be able to look at through a telescope. Righto. If we turn our chair to the northwest, directly north lies the constellation Orion, the Hunter, seen in the southern hemisphere. Hang on a sec. Just go back to me there. Seen in the southern hemisphere upside down. The famous three stars of his belt are called or named, and they're horrible Latin names, Mintaka, Allinum, and Alnitak. That'll do. From his belt and going upper right is a line of stars which forms the sword. In the centre, which is the beautiful Orion Nebula, which I took a quick gaze at last night or the other night through a pair of binoculars. You can easily see that. A vast stellar nursery of 1,500 light years from us. Upper left in Orion is the blue-white supergiant star Regal, and the lower right is the red supergiant Betelgeuse. Orion's three belt stars are also marked, which also mark the base of the southern hemisphere's Saucepan asterism. Very, very easy to see. To the northwest is the open star cluster of Hades, 153 light years away, and forms the inverted V of the head of Taurus the Bull. The red giant star Aldebaran at its lower right corner is much closer to us at 65 light years. To the left are the Pleiades, a close cluster of young blue stars 430 light years from us. These stars formed together and are gravitationally bound together, although over millions of years it is expected the cluster will slowly disperse. Also known as the Seven Sisters, and for many cultures it represents a group of ladies. If we turn to the southeast, to the southwest, the Southern Cross and the two pointers, Alpha and Beta Centauri, are low in the southeast. In the southwest are the two small nearby galaxies, the Magellanic Clouds, named in honour of the 16th century explorer Ferdinand Magellan, I think that's how you pronounce that, who embarked on the first circumnavigation of the globe. They look like faint fuzzy patches, but are best seen away from the city lights. The earliest known physical depictions of them are in the petroglyphs in South America. Arcing across the night sky and slowly wheeling as the Earth rotates during the night to the east is the majestic Milky Way, billions of distant stars of our own galaxy. In visible light, our view of the galaxy is largely restricted to our local spiral arm, which is one of several that sit in the disk of the galaxy. We are looking edge on into the flat disk of these billions of stars, if you can imagine that. By contrast, the two darker sides of the night sky are a view out from the galactic plane. In those directions we've seen far fewer stars for a few thousand light years before intergalactic space begins, if you can follow that. The International Space Station orbits every 90 minutes at an average distance of 400 kilometers above the ground. It appears like a bright star moving slowly across the sky, Here are some of the brightest passes this coming month, although there are many others, but the ones listed here at least. In the morning on Monday the 17th, there's a passing at 6:51 a.m. to 6:58 a.m. coming in from the northwest to the southeast. Then on Thursday the 20th, there's a passing at 6:04 a.m. to 6:08 a.m. Coming in from the west-northwest to the southeast. As Tanya says here, heavensabove.com gives predictions for visible passes of the space station and major satellites, live sky views and 3D visualizations. Be sure to first enter your location under the configuration file. But that Heavens Above is an excellent site. It's been around for ages, and it caters for all celestial objects, including all satellites that are orbiting around the sun, around the Earth. Okay, 10:31 already. On this day, I won't read out all dates. It goes on forever. On this day, tomorrow at least, on the 1st of March 2003, the Space Shuttle Columbia disintegrated on re-entry, killing all 7 astronauts and halting the Space Shuttle program for over 2 years. Also on the 1st of March 1970, US astronomer Vera Rubin finds evidence of dark matter by studying motion of stars and galaxy rotation not consistent with Newton's laws. On the 3rd of March 1996, Luna 9, USSR, made first soft landing on the moon and sent first panoramic images from the Ocean of Storms location. On the 4th of March 1976, Lunar Orbiter 3, USA, launches to the moon to select Apollo landing sites. On the 5th of March 1963, Dutch astronomer Martin Schmidt discovers quasars, quasi-stellar radio sources. On the 7th of March 1979, Pluto moves inside Neptune's orbit for the first time since its 1930 discovery. On the 8th of March 1969, the Allende meteorite, the largest meteorite found, lands near the village of Allende in Mexico. Right. On the 9th of March 1986, the first module of the Mir space station, USSR, is launched into Earth orbit. Also on the 9th of March 1986, last visit of Comet Halley, met by a flotilla of probes, notably the ESA's Giotto, with Comet's next return due in mid-2061. On the 9th of March 1473, birth of Nicholas Copernicus, famous for his sun-centered theory on the revolutions of the celestial spheres, 1543, which triggered the Copernican Revolution, that one. And I'll finish on this last one. Also on the 9th of March 1975, Soyuz 12 USSR returns to Earth, setting Soviet record for 29 days in space. And one more. On the 11th of March 2003, first measurements using the WMAP, the Wilkinson Microwave Anisotropy Probe data to reveal the relic Big Bang temperature as a variation across the universe. Right. Anyway, I'll leave that there. I'll finish off the rest of those dates later. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Let me just have a quick check of mail. Yep, email there from Steve. VK3SBX, 30 over 9, and Discord is good. All right, and thanks for that. And a quick look at Discord, just to see if there's anybody in. Steve's watching, and our resident Mount Burnett astronomer David KDM is listening there too, or watching at least. Okay, and in the chat room, is there anybody in the chat room? We have Brendan, VK3BKO, Steve again, and David again, and Brendan, VK3BKO, yep. And they're all chatting there amongst themselves, that's fine. And a nice little picture there of a globular cluster. Globular clusters are really, really amazing to see. They are just beautiful objects to look through a telescope on. Okay. Now, things are moving along here. It is time goes so quickly. Alright, this one here. Okay. Thanks to Robert for sending me this one. Science alert. Let's see. A mystery of weird signal detected. I knew I was going to cough. A mystery of weird signal detected in the Australian desert finally solved. Dated 22nd of February. And there's an image here that I can just throw up on the screen so you're not always looking at me. Did I bring it across? Yes, there it is. Although I can bring up a little insert there as well. Yep, there's me again. Anthropogenic signals are a huge problem in radio astronomy. In the process of solving a curious mystery, US researchers have now come up with a technique that could better filter our own radio noise from space signals. We humans are loud in radio waves. We use it for communications, of course, of all kinds, but much of our technology is a source from electrical appliances and power lines down to spark gap ignition in gasoline-powered vehicles. Gasoline. This occasionally has led to some interesting problems, the most famous perhaps being a microwave oven that created puzzling signals in radio telescope data. Scientists at Brown University in the US recently identified another puzzling signal, and it could lead to improvements in radio astronomy. The signal itself came from a television. That's not the puzzling part. The puzzling part is that the Murchison Wide Field Array that made the detection in the remote Australian desert outback in 2013 is in a designated radio quiet zone, a large area locked down tight against any anthropogenic radio interference. Nothing that can leak radio waves is allowed in that area. The facilities are all housed in Faraday cage building. Any cars driving into the zone need to run on diesel engines. Yet here was a television broadcast signal streaking across the sky as bold as you please. It then hit us, says physicist Jonathan Prober, P-O-B-E-R, of Brown University. He says, we said, I bet the signal is reflecting off an aeroplane. We'd been seeing these signals for close to 5 years, and several people had suggested that there were airplanes reflecting television broadcasts. We realised we might actually be able to confirm this theory for once. Radio frequency interference in our increasingly technological world is becoming harder to avoid in radio astronomy. One of the biggest potential problems in the sheer volume of satellites being launched in constellations that number in the thousands. Researchers have shown that some of these satellites are leaking radio waves in the range reserved for astronomy. Terrestrial radio quiet zones can shield instruments from interference generated on the ground, but currently there's no way to block out signals from overhead. Astronomy is facing an existential crisis, Prober explains. There is growing concern that even some reports that astronomers may soon be unable to carry out high quality radio observations as we know it due to the interference from satellite constellations. This is particularly challenging for telescopes like the Murchison Wide Field Array, which observes the entire sky simultaneously. And I've got a close-up here of one of these antenna fields, which I think we've all seen over time. There it is, up on the screen now. There is no way to point our telescopes away from these satellites. Previously, any data polluted by anthropogenic radio interference was simply discarded, since it was too hard to isolate and extract the contaminating signal. But going into the future, the solution is unattainable. Prober and his colleague physicist Jade Dumacher of Brown University thought that if they could find a way to isolate the television signal reflecting off passing aircraft, they might be able to develop a way to track the interference signals. The tool required to extract them and reclaim the usable radio astronomy data. To characterize the signal detected by the Murchison Wide Field Array, the researchers used multiple methods to refine the data. The first was a technique called near field corrections, which applies a stronger focus to nearby objects, as opposed to the deep space observations normally made by radio telescopes. The second is something called beam forming, a technique that sharpens the curved near-field signals received by the Murchison Wide Field Array. Together, these techniques allowed the researchers to identify the source of the signal as the aircraft cruised at an altitude of 11.7 kilometers and at a speed of 792 kilometers per hour. They even narrowed down the source of the broadcast. The frequency was one associated with a digital TV channel used by Australia's 7 network. They were unable to identify the aircraft responsible, however, because publicly available flight logs didn't exist back in 2013. But the conclusions the team was able to draw shows that it is possible to extract radio interference from the data, thus preserving what could be significantly or scientifically valuable observations that would otherwise have been scrapped. This is a key step toward making it possible to subtract human-made interference from the data, Prober says. By accurately identifying and removing only the sources of interference, astronomers can preserve more of their observations. Reduce frustrating data loss and increase the chances of making important discoveries. Only time will tell how severe the problem will grow in the years to come, but the work of Ducharme and Prober suggests that there may be a way forward for terrestrial radio astronomy, at least for a little while longer. The research was published in the publications of the Astronomical Society of Australia. Righto. All right, now I'm going to actually go straight across to Tamitha Scove because I know she's got a report that goes for about 15 minutes, and that'll just tie up the whole rest of this session tonight. So let me see now. Let me see. Where's my camera? Let me just pick up my camera first. Get rid of this guy. And okay, stand by for Tamitha's latest solar report. This is about a day old so far, but it covers all the weekend. As soon as I can find it, there we are. And I think if everything is kosher, everything should play okay, hopefully. You're tuned to ASV Radio, VK3EKH. Stand by for the Space Weather Woman, Dr. Tamitha Skov.
We have some big solar flares, a far-side blast, a radiation storm, an Earth-directed solar storm, some fast solar wind. Boy, is our sun waking up. Those stories and more in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week is picking up in a big way. As we take a look at our Earth-facing disk, we do have a lot of active regions in Earth view, and some of them have gotten quite busy over the last couple days. We've also had quite a few solar storm launches. Most of them have been pretty small, at least early on. You can see a little filament eruption here. You can see pow right there. That was an Earth-directed solar storm. But most of these, as they've hit or grazed by Earth, really haven't yet amounted to much, so we haven't been all that excited. However, all of that changed right around the 21st. You can see this filament up here in the west. It lights off in a gorgeous display. Look at that whoosh. And that is because it was pinned between region 3989 and region 4001. And this kind of started like a signal that all of the activity is going to start ramping up now. We're seeing region 4001 starting to fire big solar flares along with region 4000. We've popped like 6 big flares over the last 3 days. In fact, you can see 4001 on the 23rd begin to pop big M-class flares. There was one. And then it pops an X2 flare. You can see late here on the 23rd. Wait for it. Pow, right there. That was an R3 level radio blackout. You can see it right there. And even though it didn't last all that long, because this flare was occulted, meaning that the region was rotating behind the sun's west limb, it blocked part of that flare. A lot of people that are amateur radio operators noticed the big radio blackout, and that's because this thing had a lot of energy. We had a radio burst up to 18 gigahertz, and that even affects Starlink. So some of you Starlink users, you might have, if you've had any dropout or any dropouts during the 23rd, well, now you know why. Anyway, after that, we actually been paying close attention to region 4000 as well, because if you look at this region in here, you will see pow, right there. That was an M-class flare, but did you see the dimming that happened? That actually was an Earth-directed solar storm, but it was hard to see because once again, I'm going to back it up a little bit, this region fired at the same time. Watch, you can see that dimming region and something release right there at the same time. So we've got another Earth-directed solar storm, but it's kind of camouflaged, so there hasn't been a lot of model runs on it. But we'll talk more about that when we get into the stereo imagery. Meanwhile, keep your eye on this part of the sun right here. You'll watch it whoosh. Did you see that? That was a massive solar storm launch. In fact, as we take a look at this far side blast, look at this coronagraph signature. It's absolutely massive. It also launched an S1 level radiation storm, which we're dealing with right now and will likely be near S1 levels over the next 24 hours before things begin to calm down. But believe it or not, that's still not the only story. We've got region 3996 right here and 3998, and you'll see pow right there. There's yet another big solar storm. This one is nearly Earth directed, but it looks like it's going to miss Earth off to the west. So while these regions continue to rotate in through Earth view and rotate to the sun's west limb, we're going to continue to have these big solar flares as well as potential solar storm launches headed toward Earth. So we need to stay on our toes over the next couple days, but then things hopefully will start settling down. And now switching to our far-sighted sun, we're finally able to use stereo A imagery again because stereo A has moved to the side of Earth enough to begin to see the far side. In fact, you can see here's Earth, Here's the sun, and here's stereo A staring at the sun just a little bit from the side. So some of these active regions might be familiar, but we can see further away. In fact, here is that filament region that we were talking about earlier, that sandwich between region 3989 and region 4001. And you can watch this thing on the 21st. Look at that gorgeous eruption. And as it continues to move on, you'll see it continue to light up several times and launch more than once. Now here's region 4000, and this is the area that on the 24th launches that Earth-directed solar storm. You can see that dimming right here, but you can also see that big filament channel had also lit up. So when we take a look at stereo coronagraph imagery for this, sadly, here is the big eruption from that side. Right, you can see it, this eruption going off to the side right there. But if you look super carefully, you see something else that looks like it could be part of a halo. We think it's this eruption here, but my goodness, this is super hard to model. Look at that. You see this little kind of line going through here? That looks like that's part of this eruption. But my goodness, it's very difficult to get a decent forecast. So we do think that there's something coming, but it is, as you can tell, camouflaged. So that becomes the biggest problem during really active times like this, where we just don't have enough enough images to be able to separate all of these different eruptions when they occur. Meanwhile, you can see that big coronal hole rotating very clearly, and you can watch, look at that big eruption. This was that big far-sighted blast that caused that big S1 level radiation storm. So we are going to be watching region 3991 as well as 3989 and 4001 as they rotate to the sun's far side and survive their far side passage, because they could be big flare players as things return here in about 2 weeks. Now, switching back to that Earth-directed solar storm, we take a look at our solar storm prediction model, ENLIL. Now, this is NASA's version of the model, and you're looking down at the sun from the North Pole with Earth being off to the right. And as we set this solar storm model in motion, you'll see that solar storm being launched. You can see it here. It's going to be kind of a glancing blow, but it's expected to be hitting Earth late on the 26th into the 27th. Likely it'll be a bit fashionably late. We're hoping it's going to be a little bit more of a direct hit than this glancing blow, but again, because of the coronagraph imagery, it's really hard to tell. So this is just an estimate. So aurora photographers, if you're at high latitudes, you're definitely going to get a show, because it's likely going to be coming in with the fast wind stream. You can't really tell here, but this blue right here is the fast solar wind. So it will be kind of on the front end of that fast solar wind, which could give us some enhanced effects, and it could actually bring aurora down to mid-latitudes. Switching to our moon, we are passing through the third quarter phase on our way to a new moon, with the new moon being on the 27th. And by the 3rd, the moon will still be about 15% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora, well, now is your perfect chance. Now, stepping outside to take a look at our live conditions using our global geochron map, the first thing we take a look at is the radio blackout threat meter using DRAP, and you can see it's quite colorful, and this is mainly because of the radio blackouts due to solar flares on Earth's day side. You can see them lighting up like this, but it lights up like a Christmas tree as soon as our S1 radiation storm hits, and you can see that here at the poles. But luckily, we don't have any issues on Earth's night side. That is very typical. Amateur radio and HF radio propagation seems to be pretty good, at least at the beginning of this radiation storm, which occurred the latter part of the 24th. But as we flip to our GPS scintillation risk, also known as ROTI, it's an index that talks about where GPS signal degradation could be very, very high. We take a look and see, as that radiation storm began to peak, we really see a lot of activity down here at low latitudes, especially located near central part of South America, but it also stretches clear out into Hawaii area and also to West Africa and South Africa as well. This is kind of the Bermuda Triangle of space weather right here. It's called the South Atlantic Anomaly. And that really began to peak and cause some real problems for GPS users in this area, and it will likely continue to over the next day or so as that radiation storm continues to wane. As a matter of fact, as we flip back to our DRAP model, you can see the radiation storm is beginning to die down here over the next, over this coming day. The colors are beginning to kind of go back down. So that's good news there. But these radio blackouts continue to cause problem for HF radio on Earth's day side. You'll see there's a M3.6 class flare, and you can see at that near R2 level radio blackout, you can actually see the amateur radio signals kind of get weak in that region before the thing begins to die down. So this is going to be the conditions here it's been the conditions over the last 24 hours and will continue to be the conditions as we move on into the next couple days. But as far as aurora is concerned, well, we've actually not been seeing all that much aurora over the last couple days. However, aurora is beginning to build now. Over the last few hours, you can see it start building like this. And that's going to be on our way to getting that fast solar wind along with that solar storm that's on its way to Earth. That should be hitting us right around the 26th. So aurora photographers, it looks like we're beginning to get some preconditioning here with the aurora. So it's good news because that could mean aurora will definitely make it down to mid-latitudes. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the hit from that Earth-directed solar storm, which should be followed by a fast wind chaser. So at high latitudes, NOAA is expecting active to possibly minor storm conditions with up to about a 50 or 60% chance of a major storm. Somewhere in the 27th is probably when we're going to see the peak. And then things will slowly kind of wane a little bit because we have that fast solar wind that should give an extended aurora show for you high latitude observers. Now, mid-latitudes, we're only expecting unsettled to active conditions, but we do have up to about a 30% chance of a major storm. It really depends upon how much of a glancing blow that Earth-directed solar storm is. Remember, this is that solar storm that was really hard to predict because it was basically camouflaged in coronagraphs. So we have a lot of error in this one. That's why you're seeing the difference between active and major storm. Really don't know. It could be, anything in this very wide margin. So just keep on your toes if you're a mid-latitude aurora photographer. We could actually see some impacts from the high-speed wind as the stream kind of comes through. That could give us a chance for more aurora as well. So I'm keeping the active possibilities out through about March 1st before things begin to finally calm down. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting at the high 190s, which will likely die down just a little bit as a lot of these really active regions are rotating to the sun's west limb and will soon be disappearing to the sun's far side. We are still sitting at moderate noise on the bands, and I've stretched that out through the 5-day. NOAA's giving us about a 65% chance of M-class flares. This is at the R1 to R2 level radio blackout, and that will continue over the next few days, but expect a tapering off of that as well. So expect the noise on the bands to disappear, die down at least a little bit. We also have about a 25% chance of X-class flares at the R3 level radio blackout. That's also going to start dwindling about Friday into the weekend. Things should be calming down just a little bit. And by next week, things should start getting really quiet. So amateur radio operators, just hang in there because these solar flares will likely die down over this next week. And then the week after, things might start getting active again. And now switching to our radiation storm and polar aviation outlook over the coming week. Well, sadly, not everything's in the green this week. We are sitting at the D2 minor range. This is at flight level 360 for you aviators. It's also the S1 radiation storm for level for everyone else. We are dealing with stormy conditions right now. We're kind of hovering in and around that S1 level. That might actually peak a little bit above the S1 level as we move into the 27th. It's kind of hard to tell as that solar storm goes by us, but then it should drop reasonably quickly. NOAA's giving us about a 95% chance of staying at that S1 level through the 26th. It drops to about a 55% chance on the 27th, and then it continues to precipitously die down after that. So expect by March 1st or 2nd, we'll be back into the green. You frequent flyers, and this does include air crew and you high-risk passengers, please take care and take a look at those ICAO advisories. Pay attention to them because things can change very, very quickly. And please take these issues into consideration in your flight plans. So the space weather this week has gotten very active. Not only have we had a number of big solar flares, but we also have an Earth-directed solar storm. Now, of course, this solar storm may be a glancing blow, but aurora photographers, if you're at high latitudes, you could get an extended show. And aurora photographers at mid-latitudes, well, with that new moon, there's a very good chance that you're going to see something, even if it's for a short little bit. So be sure to keep on your toes. Now, amateur radio operators and emergency responders, well, I know the bands kind of aren't that great right now. We've got a lot of radio blackouts, and that radio blackout risk is remaining reasonably high. We also have that big radiation storm, and that's not helping either. So you're just going to have to kind of tough it out over the next probably 3 to 5 days before things begin to kind of calm down. And next week looks like it's going to be a lot better for you. So just hang in there. And now you GPS users, well, you know, that radiation storm isn't helping too much when it comes to the poles. So navigation and reception is going to be pretty bad up there. Also on the night side, it's not helping very much if you're at low latitudes anywhere near that, you know, space weather Bermuda Triangle that we call the South Atlantic anomaly. So be aware of that too. And then, of course, near dawn and dusk, that's not the greatest because of these solar flares. And oh my goodness, when the solar storm hits, you're not going to want to be anywhere near Aurora either. So I think you're getting the worst end of the deal of everybody this week. So just hang in there and fly with vigilance, and be sure to calibrate your magnetometer often. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay. Let's see, where am I? Audio. There we are. All right. 1, 2, 3, 4, 5. Good. Thank you, Tamitha, for a really extensive report, that one. I think it was really interesting how she was using the geochron map for some of her observations. I've actually I've recently purchased one of those things, 4K resolution Atlas II geochron, and the which is running just over on the screen over yonder. And I've emailed Tamitha about those some of those screens that she was on display. So I'm hoping I might be able to grab hold of those myself to have on the screen here as well. Thanks, Tamitha, for that. Okay, now the one thing I want to show tonight, which was featured on the 6 o'clock news tonight, I think this is really, really interesting stuff. I had so many other things to talk about tonight, but the sky notes always take up a lot of talk time. Let me see if I can just cue this up. No. Back to vMix. I've got it here somewhere. That's it. Yeah, okay. All right. Now I'll just run this to the screen. I know there's a few. We've got a few. I'm watching YouTube, and there was up to 7. Actually, there's up to 8 people now on the YouTube side of things. So that's fairly impressive. I just hope it doesn't fall over. But stand by and have a look at this. Let me run that, and I've got this on a loop. Yep, it's on a loop. Right. For those watching the the TV repeater and Discord and YouTube, Struth. Apologies for that. This image you're seeing on the screen right now is very important. Fair dinkum. A lot of the posts on space.com and elsewhere on Facebook, so many people, mostly in America, really stupid people. It's just stupid the way they think this is fake, and it just goes on and on. The way these people think. This is Blue Coast. What we're referring to as Blue Ghost captures stunning moon footage ahead of the historic landing. As it maneuvers into position for a landing attempt, Firefly Aerospace Blue Ghost lander captured some gorgeous video of the moon rolling away below it. The video below, sped up by 10 times, was taken about 100 kilometres above the lunar surface, showing the far side of the moon and a top-down view of Blue Ghost's RCS thrusters centre and radiator panels on each side. The Texas-based private aerospace company wrote on its live blog, "The radiator panels are moving nominally to protect Blue Ghost's subsystems from extreme temperatures. The lander module carries 10 science and technology instruments for NASA that will take measurements from the Mare Crisium or Sea of Crises, a large balsa-filled Gaussian domes on the near side. All three missions will provide invaluable data to help NASA assess longer-term lunar habitability prospects, such as a permanent moon base. Blue Ghost descent into the Mare Crisium will commence on March 2, and we'll all be waiting with bated breath, they say. Landing on the moon is still extremely difficult. There's no atmosphere to speak of to provide a natural drag to help the descending spacecraft brake using a parachute. So descent can only be controlled using thrusters. The terrain is also hard and rough, which makes error margins for descent velocity extremely narrow, they say here. If all goes according to plan, it will operate its science payload for a full day. That's 14 Earth days, capturing solar eclipse as the Earth passes over the sun and sunset. Its operation will continue for several hours into the lunar night before shutting down forever. This is normal for lunar missions. The lunar night reaches temperatures lower than minus 246 degrees Celsius, and it's challenging to keep the spacecraft operational through that transition. So the imagery you're seeing on the screen is fair dinkum, and this is what I've been saying all along about going back to the moon. Whether it be probes like this landing on the surface, or the rover coming up in 2028. Once we go back to the moon and actually have astronauts roving around, we can be sure the images that come back will be all HD, high definition. It'll be some of the best imagery ever taken of men on the moon doing their stuff. So I'm really looking forward to it. What we're seeing here is just an idea of the kind of quality of images that we're going to expect. Alright, it's getting nice. So pretty impressive. There was also a launch earlier this morning back to the International Space Station too. There was a launch, I was watching it, and it had a Soyuz spacecraft carrying goods for the International Space Station. So I'm not 100% sure whether the Soyuz spacecraft that was attached is actually also going to be used to return the astronauts that are being kind of up there for an extended stay. I haven't quite discovered the other part of the story there, but we'll try and find out something for next week. Anyway, alright, I won't worry about spaceweather.com because I think Tamitha really covered all that as well for the space weather side of things, although I can probably show you the aurora glow over the South Pole as we speak. So there's a little bit of auroral activity, but it's not very extensive. It's not reaching the mainland at this stage of the game. Okay, all right, let's go back to camera, and I think we'll call it quits for tonight. So, having said that, 7 people on YouTube, I'm about to call out for anybody wishing to, where's my writing pad? There it is. Call back. As soon as I start to intermittently transmit, we may lose YouTube, so I'm making an apology first, an early getting in an apology if the vision disappears. The modem will take probably about 3 or 4 minutes to reboot and get things working again. But I'm crossing fingers that this won't happen. So hopefully it'll be okay. But unfortunately, if the modem falls over, then I lose the 2 streams that are running here at the moment. This is VK3EKH. We'll take a quick listen on 3541 for any stations wishing to check in. All right, we've got VK3JR, VK3DX, VK3SBX, VK3BKO. Is there anybody else? Oh, there's a station that's off frequency and a little bit on the weak side. Let me just... yeah, hang on a sec. We'll do that. Just try again. Oh, no, tricky. Is anybody able to hear that station? Oh. Very good. VK6AR. Wow. All right, yeah, just a little bit off frequency, and but we'll see how we go. All right, VK6AR, excellent. All right, Frank, VK3JR, VK3EKH.
Tonight, Clint, and could you please tell us the sunspot number? That's an interesting stat because it seems to have a good bearing on bad conditions, on HF bad conditions. VK3EKH, VK3JR.
Whoop, feedback. All right, VK3JR, VK3EKH returning, very good. And I've been fiddling here trying to get the audio right to patch the audio over the digital streams as well. If I have the headphones in the radio, I kill the audio to the mixer. I couldn't work out why that wasn't working until I just realised that I had to remove my headphones, and now I've got audio to the digital stream as well. Anyway, all right. Yeah, look, if I had have called out the spaceweather.com, I would have mentioned that. It's just here. There it is. All right. The current solar sunspot number is 129. The current sunspot number is 129. The radio sun is currently 170 solar flux units. 170 solar flux units. The KP index is 4.33. The planetary K index, KP figure, is 4.33, and it is considered unsettled. The 24-hour max will be 5, and that's considered storm conditions. So things are afoot in that area. All right. Okay, thanks, Frank, and I agree with your comments too. The amount of sky pollution, so to speak, the amount of satellites that are up there with RF signals all beaming back towards the surface, it's just a radio astronomer's nightmare, and not to mention normal optical astronomers having to deal with all these satellites sky bombing their astrophotography images. Anyway, that's another story. Thanks, Frank. Okay, on the 160 missions. Greg, VK3 Delta X-ray. Have a say, VK3EKH.
Yeah, good evening, Clint. VK3EKH, VK3DX. Greg down in Warrnambool, and good evening to the others that have checked in. All good signals. Talking to Brendan, VK3BKO there earlier on. Interesting broadcast there, Clint, and yes, one wonders about all the space junk that's up there that's just building up and building up. I know it's a big panic, but at some point it must, well, maybe it never reaches saturation point. It keeps falling down, but the interference problems, can imagine. We're certainly noticing here. I am anyway. But I did notice this week on the HF bands, the conditions were a little bit better than they were the previous week. That was good. Anyway, Clint, thanks for running the broadcast. You do a great job, and good to hear you on there each week after week, mate. VK3EKH, VK3DX. Cheers, Clint, and all the best.
Yeah, good on you, Greg. VK3 Delta X-ray, VK3 EKH returning.